Hello and welcome to section 10.3, moles of compounds. Today we're going to look at the molar mass of a compound and how it can be calculated from its chemical formula, which we've done a little bit, but then we're also going to look to see how that can be used to convert from mass to moles of that same compound. And just to refresh on what we were doing last week, example 11 says determine the molar mass of the compound C2H5OH. So if you recall, we are going to break this up into carbon, and I notice because I have this number 2 here, or that subscript, that I'm going to have 2 carbons, and I'm going to have to multiply that by the molar mass. Remember, the molar mass comes off your periodic table, and if we look that up for carbon, it's going to be 12.011 grams per mole. So when I multiply 12.011 by 2, I end up with a 24.022, and again, this is going to be grams per mole. Then I'm going to do the same thing for my hydrogen. Now hydrogen, I've got 5 here and 1 here, so I really have 6 hydrogen atoms. And if we look at our periodic table, the mass of hydrogen is 1.008 grams per mole. So when I multiply this out, we end up with 6.048 grams per mole. And then lastly, I have oxygen, which we have not accounted for yet. And I can see that we just have 1 oxygen. And if you look up the molar mass of that, that is 15.999 grams per mole. So if I multiply that by 1, I end up with my 15.99 grams per mole. Now, because it asks for the molar mass of the compound, I'm now going to take and add all of these together, and you should get something around 46.069 grams per mole. For our next example, we're going to go a little bit farther this time. For example 12, it says the characteristic odor of garlic is due to the allyl sulfide, and they give you the formula. What is the mass of 2.5 moles of allyl sulfide? So just like any other problem, we are going to start with what they give us, which is 2.5 moles of C3H5, and then with those in parentheses and a 2 outside, and an S. Now I need to get to a mass, okay, so because I have a mass there, I know that my unit on the top should be grams, and I need to cancel out this unit of moles. So I should end up with something that has grams per mole. And by now, that should be kind of a flag to yourself that you have to calculate the molar mass. So usually anytime I see the word mass, whether I have to find it or I'm given a mass, you're probably going to have to find what the molar mass of that compound is. So we'll do that real quick. So carbon says that we have 3 carbons here, but I'm multiplying it by 2, so I really have 6 carbon times the 12.01 grams per mole, and that's going to give me 72.06 grams per mole. Then I'm going to have hydrogen, and I see I have 5 hydrogen inside of the parentheses with a 2 outside, which means I'm really going to have 10 hydrogen atoms. So I'm going to multiply that by 1.008, and this is going to give me 10.08 grams per mole. And then for my sulfur, I just have 1 of those, and I'm going to multiply that by 32.07. And that gives me 32.07 over here. Now, when I go ahead and I add all of these up, we'll just slide this down here, we end up with a total mass of 114.21 grams per mole. So now what I'm going to do is I am just going to put that up here. So 114.21 grams for every 1 mole. And sometimes it is kind of nice if you list out what it is, especially if we go to, as our problems get more complex. Okay, and then what you can see from here is your moles are going to cancel, and you're going to be left with grams, which is what you want. So when you multiply all of this out, you should end up with 286 grams per mole. For our next example, we have aluminum chloride is being used in refining petroleum and manufacturing rubber and lubricants. A sample of aluminum chloride has a mass of 35.6 grams. We want to find how many aluminum ions are present and how many chloride ions are present in this aluminum chloride sample. So as I mentioned with the previous example, because we are given the unit of grams, we're probably going to have to convert from grams to moles at some point in time, so we need to find the molar mass of aluminum chloride. If you recall, aluminum chloride is really AlCl3. So when we go to find our molar mass of aluminum chloride, we have 1 aluminum. So for aluminum, we have 1 times the molar mass of aluminum is 26.98 grams per mole. And chlorine, I have 3 chlorines, and the molar mass of this is 35.45 grams per mole. So when I multiply these out, I get 26.98 grams per mole, and I end up with 106.35 grams per mole. So when I add these together to find the total molar mass of the compound, I get 133.33 grams per mole of aluminum chloride. The next thing we're going to do is we're going to start out with what we were given, which was 35.6 grams of aluminum chloride, so AlCl3. And then we're going to use our molar mass that we just calculated to convert everything over to moles. So my grams are going to have to go on the bottom. So 133.3 grams are going to go on the bottom for every 1 mole in the top. When I cross out my grams, I'm left with 0.267 moles of aluminum chloride. Because our problem asked us to find how many aluminum ions and chloride ions are present, if you remember, ions are considered a representative particle. So what we need to do is we need to take our moles of aluminum chloride and put them in terms of another representative particle. So aluminum chloride then we can say is a formula unit. So I'm going to take this 0.267 moles of aluminum chloride and convert them over to a formula unit of aluminum chloride. And I'm going to do that by using Avogadro's number. So if I take my 0.267 moles of aluminum chloride, which is AlCl3, okay, and I convert this to formula units, remember Avogadro's number is 6.02 times 10 to the 23rd, and this is going to be formula units for every 1 mole. So now what's going to happen, my moles will cancel, and if I multiply 0.267 by the 6.02 times 10 to the 23rd, I end up with 1.61 times 10 to the 23rd formula units of AlCl3, and I'm not going to be able to fit that. So it's AlCl3. For aluminum ions, we're going to start out with our 1.61 times 10 to the 23rd formula units of AlCl3, and we're going to use this along with the number of ions that we have. We have one aluminum ion for every one formula unit of AlCl3. So this is going to give us, my formula units are going to cancel, and I'm left with an aluminum ion, so I have 1.61 times 10 to the 23rd Al3 plus, or aluminum ions. Okay, so this is our aluminum ions. Now I'm going to do the same thing, except I'm going to do it with chlorine ions. And because chlorine, I had 3 chlorine atoms in the one formula unit of AlCl3, the only thing that's going to be different is I'm going to put 3 Cl minuses up there. So our last step is to take our 1.61 times 10 to the 23 formula units of AlCl3, and this time I see that I have 3 chlorine ions for every one formula unit of AlCl3. So again, formula units will cancel, and now I've got 1.61 times 10 to the 23rd times 3, or this is going to give me 4.83 times 10 to the 23rd chlorine ions. And that's how you'd find individual ions out of the compound unit of AlCl3. And that concludes this part of section 10.3.